Tatiana from Tatiana Math Resources. We're going to be looking at calculating the gradient of a straight line. Our objectives are: 1, define gradient. Then we're going to explain how to use the formula to calculate the gradient. Then we're going to calculate the gradient given 2 endpoints. And then 4, we're going to be given a graph with a straight line, and we have to state the coordinates of 2 points on that straight line. And then we're going to use the second method of finding the gradient, the rise over the run. Gradient. It is also known as the slope of a line, and it shows how steep it is. To calculate the gradient, this is the formula: y2 minus y1 over x2 minus x1. And these are usually two sets of coordinates. So you would have A is x1, y1, and B is x2, y2. There's also a second method, or a second way of looking at it, is when you have these 2 points here, you form a right angle triangle, and then you count the change in y, which is here, over the change in x, which is also known as the rise over the run. Now, there are different types of straight lines. So the first one there, you can see you have a straight line here, and it's saying it's a negative slope, in that when you take 2 points, A and B, as you can see there, and you plug it into the gradient formula, you're going to get a negative gradient. Our second example is a horizontal line. You have 2 points, A and B. When you use those 2 points to find the gradient, you're going to get 0. Third example is you have a line, as you see here, you're going to get a positive gradient. So when you take these 2 points, A and B, plug it into the gradient formula, you're going to get a positive gradient. And last, if you have a vertical line, you take 2 points on that straight line, on that vertical line, plug it into the gradient formula, you're going to get an error. It's undefined. Example 1, a straight line passes through R23 and S46. Determine the gradient of the line. So first step, we have the formula. Second is we're going to label R is x1, y1, S is x2, y2, and plug them into the formula. So y2 is 6, y1 is 3, x2 is 4, x1 is 2. Subtract, you're going to get 3 over 2, which is the same thing as 1.5. Here we have a Cartesian plane and a straight line. We have 2 endpoints, A and B. A and B. So the coordinates are given, and it's also labeled x1, y1, x2, y2. So first step, formula. Second step, plug them into the formula. So y2 is 4, y1 is -2, put that in brackets, x2 is -3, and x1 is 3. We know that we have 2 negatives here. It's going to give us a positive. So 4 plus 2 is 6. And -3 minus 3, we add and keep the sign. So we're going to get -1. A positive divided by a negative, we're going to get a negative. Example 3, we have here again a Cartesian plane and a straight line. So what we're going to do is to take 2 points. So I'm going to use a different color, and I'm going to take this point and this point. We're going to draw a line, come straight down, and then come across, and it forms a right angle triangle. We're going to count the squares: 1, 2, 3, 4, 5, 5 units. I'm going to do the same thing here: 1, 2, 3, 4, 5, 5 units. So this is the rise, and here is the run. And remember, it is the difference in y over the difference in x. So the gradient is equals to 5. Well, let me write what it is first. The rise over run, and it's equals to 5 units over 5 units. And that is equals to, we cancel, 5 to 5 is 1, so we get 1. So the gradient is equals to 1. It's your turn now. Here we have our Cartesian plane, the straight line. You're supposed to take 2 points on this straight line and calculate the gradient. Looking forward to seeing your answers in the comment below. This is Tatiana from Tatiana Math Resources. We looked at calculating the gradient of a straight line. Thank you so much for watching my video. Don't forget to like, subscribe, share, or leave a comment. Stay tuned for more.